Class.
400 BS.
ಯಾರು ಸ್ಟೂಡೆಂಟ್ಸ್ ಬಂದಿಲ್ಲ. ಬಂದಿದ್ದಾರೆ 11 ಜನ ಇದ್ದಾರೆ ಆಲ್ರೆಡಿ. Exactly time. So good morning, good afternoon, dear students. Am I audible? Somebody please.
Good afternoon, sir.
Yeah, good afternoon. Thank you.
Audible, sir.
Yeah, thank you, Pa. Thank you. So we'll start today's class. Today's class is very important, with respect to examination point of view. And not only that, for your life point of view also, it is very important. Okay, exactly it is 12:10. Let us start. Actually 1 minute is already done. 12:11. So we have sufficient participants. We'll start. Okay, today's class agenda would be on discussing on internet working. We call it as IP. Internet working protocol. How exactly internet working? What is exactly internet working? What is the protocol that it has to follow? And what was the difference between the earlier methods, that is bridging and switching? How it is different from internet working? This is what we have to understand. And at the end of the class, we'll discuss about internet protocol, frame format, IPv4. We call it as version 4. Still, version 6 is not yet implemented in India. So most of the times they ask questions on IPv4. Okay. So in the previous section, we saw that it was possible to build reasonably large LAN bridges, but such approach has a limitation. So bridges and switches, if you can use it only with respect to LANs. If you want to connect heterogeneous networks, so it becomes a, what do you call the limitation. It becomes a heterogeneous, becomes a limitation. So the limitation of bridge network is to enable the building large, the major limitation of bridge network or switch network is they cannot provide heterogeneous in the sense, so you cannot have different kind of networks connected using these bridges. So that is a major problem. So we use a technique. To interconnect heterogeneous networks. We call it as internetworking. So internetworking is nothing but it is the interconnection of heterogeneous various types of networks. How it is done? So by employing a device, we call it as a router, or the entire processing, we call it as a routing. Router is one such process, such device that certainly interconnects multiple networks, different types of networks. Suppose I want to connect LAN with the Wi-Fi system, or Sudanva, you have any question? You have raised a hand. Okay, if anybody has a question,
no sir.
Please raise the hand.
No sir, by mistake.
No problem. If anybody has this one doubt, please raise the hand so that we'll make even the online class interactive, more and more interactive. So definitely we can do it. Okay. And last week one of my student asked this question. Sir, what is, sometimes some people write internet I small, internet I capital. So is it really I small or I capital. So I told that student we will discuss in the upcoming class. So the time has come. So when we use the term internetwork, so it is sometimes just internet. So internet with I small. Observe here, I is small. I with lowercase I refers to arbitrary collection of networks that are interconnected. So if you interconnect many networks, so certainly you can write that as internet. You can write it as internet with the I small. So you can write it as internet with I small. And if you interconnect a global collection of networks, then we call it as internet with I capital. You can see with I capital, you can certainly write I capital. You can certainly write. So that is the difference between small I. Many times in the interviews they ask this question: what is the difference between internet and with small I and capital I? So small I refers to interconnection of networks, internet. So and capital I is a global collection of internet. So in the examination when you are writing internet work, so write I small. So that is the point that I would like to bring it to your notice, right? So further, if you look at this particular diagram, please look at this diagram. So you have a Wi-Fi system here at the bottom. You have a Wi-Fi network. So where access point is connecting H4, H5, H6, H7. So it is connecting various networks. It is connecting various networks. So it's a wireless network. So the network that we have is a wireless network. This is network one. Further, network 2 is a LAN Ethernet. Okay, it is an Ethernet LAN. And between LAN, we have a router. And observe here, LAN, Ethernet and Wi-Fi system are connected through router R1. Router R1. It is not the switches now. It is routers. Routers are also called as gateways. And of course, you can connect router to router to interconnection. Router to router you can connect. So we call it as a point-to-point link. So because there is a direct connection between one router, if the same kind of devices are connected together, so we call it as a point-to-point link. So we have discussed that. And this is a point-to-point link. And network 4, which is connected by Ethernet. And observe here the first point. An internet network is often referred to as a network of networks because it is made out of many small networks. That's the first point. Second, in this figure, you can see Ethernet, wireless networks, by point-to-point links, etc. So you have three different types of networks that you are having. So wireless network, Ethernet, point-to-point network, etc. And each of these is a different technology in the network. And of course, the interconnection of these different networks, you can certainly do it with the help of routers. So routers are also called gateways. So gateways are the routers. They will connect different types of networks. So heterogeneous network connection can be achieved using this routers or gateways. Normally we call it as routers, right? So you observe, so internet protocol is running. So internet protocol is running. So internet protocol is, internet protocol is running. Okay. In order to connect these heterogeneous networks, so normally in the previous section we discussed about Ether network, so bridge network. So now it is internetwork. So internetwork protocol, internet protocol IP is the key tool that is being used today to build scalable heterogeneous networks. one way of thinking this IP is to run all the nodes in a collection of network that defines the infrastructure that allow these nodes and networks to function as a single logical network. The same internet protocol is running in internet layer. In TCP/IP, we have first subnet layer, later internet layer, later we have a transport layer, later we have a application layer. So, internet layer, connects to various different types of networks. For example, let us see this example that is being shown here. So, in the figure H5, I take the H5. This is a H5 node. You can see H5 node and H8 are logically connected by internet. Okay, very, very important. You see H8. H8 is here. You can see, sorry, you can see here H8 is here. So H8 is here. And observe very keenly. So H5 is in Wi-Fi network. H8 is in Ethernet, another Ethernet. So in order to reach that, you have to cross a lot of other networks. You have to go to R1. You have to go to another network, Ethernet, and later you have to go through point-to-point network. R2 and R3, and finally you should go back to Ethernet and finally reach 8. So that are logically connected by Ethernet, including the protocol graph. You can see that protocol graph. So, and observe the frame format of Ethernet is different. The frame format of wireless network is different. The frame format of point-to-point network is totally different. And what happens, the higher layer level protocols such as TCP and UDP are only same, but their lower level frame formats are totally different. So how do you send? That is the biggest question. So here H5 is one node, H8 is another node. So what happens? H5 transmits the data and converts its data to 802.8. The frame format we were seeing the host H5. If it is wants to communicate to H8, it is in 802.11. So the 802.11 is nothing but wireless network. Yes. So this wireless network goes to internet protocol in R1. So in R1, what happens? It is being converted into the next outgoing network, that is Ethernet. It automatically converts it into Ethernet. So router not only connects heterogeneous networks, but also converts one frame format from one type of network to another type of network. So it will convert to Ethernet, and R2 will convert Ethernet, frame format to PPP. It is point-to-point protocol. So you can see here, point-to-point protocol is running here. So point-to-point protocol is running here. So it has been transmitting, and this PPP point-to-point protocol is again connected back to Ethernet. So that is R3, and Ethernet it is connected, and in the Ethernet we have host 8. So you can see from this R3 again the data goes to Ethernet, and finally it reaches the internet protocol and TCP protocol and application protocol. So this is how the exact transmission of data happens. But one common thing among all these things, all these nodes, even though they are in different network, they have common internet layer, they have common TCP layer, and they have common application layer. So, but the physical layer, the subnet layer is totally different. Subnet layer is totally different. So that is what you have to understand and consider. So that's the first point. And in order to send data like this, okay, Router's main job is to transmit the data from one different network to another different network, one different network to another different network. So it will transmit and it will send. And not only that, uh, it is transmitting from one type to another type. So take for example the size of our size of 802.11. The packet size is different, and Ethernet packet size is different. P2P packet size is different. Ethernet again packet size is different. So conversion of data, conversion of packet size, scaling, dividing, again creation of packets, everything will be taken care by your router. Router will convert it and send it to the outgoing network format and transmits the data. That is one very important thing that you should understand. Further, the entire thing will go through internet, packet. So a common internet packet. In the many times in the examination, they ask us discuss about IPv4, Internet Protocol version 4. Internet Protocol version 6 is the latest one, but latest one it is even though we are using you know the 3G network or 4G network in our mobiles or in labs, LANs, whatever we are using. So it has not been implemented. So we are still using IPv4. Many times they ask. So IPv4 has lot of fields. So it has a header. See, these components, we call it as headers. So this component is header, and this is your body of the frame. So so you have to understand very clearly. You have to understand very clearly that in the header section you have lot of fields. The first field is version. So version is the fourth version we are using. Fourth version, IPv4. The same thing if you are using IPv6, the version value will be 6. So it will certainly hold the bits 0, 1, 0, 0. 0, 1, 0, 0 is nothing but it is 4. The value 4. It indicates that frame format, the packet format, what you are using is 4, version 4. So that is what you are supposed to understand. And further, moving further, next, internet header length. So what is the total length of the entire header? So this is the header. So up to here, it is the header. So what is the total length of the header? So that is what, so it should contain. So what is the header size? So header size will be recorded here. It is called IHL. This is 4-bit. Tells about how many bits are there. What is the length of a header? So that will certainly be recorded here. And you have various services. What type of service that this particular frame format is giving? So differentiated service. What is that? Type of service, TOS. It is also called a type of service. A service type or if it is transmitting the data, okay, you are transmitting the data service. If you are sending the acknowledgement service, if you are using some other service like ECN. What is ECN? Explicit congestion notification. So telling all the nodes that oh, next there is a congestion. Congestion means traffic jam. So network traffic jam is there. So what it will do, it will just like acknowledgement, it will send the node that senses the congestion will send back to all the nodes. It actually floods all the nodes the ECN packet. ECN packet is nothing but a exclusive congestion notification, explicit congestion notification. This will be sent And this particular, in that data, in that entire IP packet, so ECN, bit is enabled. When ECN bit is enabled, everybody knows. So there is a bit, there is a congestion in this particular line. So it will never transmit. Those line will not be used for further transmission. So that is what we have to understand. Further, that's what differentiated services, we have code points. So zero, starting from various services, zero indicates particular quality of service. So the DSCP defines differentiated service code points, will define what type of service, if you want, if you are transmitting video data, if you are transmitting audio data, if you are transmitting some other data. So whatever the data that you are forwarding, what is the service that you are forwarding, so that will be specified using various numbers here. And ECN is nothing but a explicit congestion notification. It carries the information about the congestion seen in the route. So that is a notification. And total length will give the total length of the entire internet protocol header and payload. So both header and payload, it will be recorded. Next, identification. Identification. It is nothing but it is the frame number. It is a frame number, or it is called packet number. So the entire message is split into packet number 1, packet number 2, packet number 3, packet number 4, packet number 5. That number is called identification. And these packets will be sent in the network parallelly across various routes. At the destination, what happens based on this packet identification number, so the entire message will be rearranged to get the original message. So initially what happens, it will be transmitting various messages, and the receiving station, so packet 1 will arrive, packet 5 will arrive, packet 3 will arrive, packet 4 will arrive, packet 2 will arrive. So it will arrange based on, it will, the destination system will arrange based on the identification number. That identification number, it should be written here. So it should be written here. You can see it should be written here. That's the thing. And flags as required by the network resources. If is IPv4 packet is too large to handle, this flag tell if fragmentation is needed or not. So suppose if it is a very big message, so automatically what happens, the intermediate nodes will fragment it. For example, Ethernet frame format. Ethernet frame format is 1500 bytes. Ethernet capacity is 1500. Whereas when it goes to all of a sudden P2P, point to point, the frame format size itself, it is 500 bytes. So 1500 bytes frame, it has to be further subdivided into 3 frames, because entire 1500 Ethernet frame cannot transmit as it is. It has to transmit as P2P frame only. So when you want to transmit P2P frame only, so what happens is the the router will automatically split the entire big 1500 frame of Ethernet into 3 parts that can fit on P2P. So it has to transmit right. So that if the flag is set, it will tell what is the total number of fragments that it has done. So that will, each packet is further sub fragmented. So that sub fragmentation will be done, will be notified in the flags. And of course, fragmentation offset. Fragmentation offset in the sense, first, I will start from 0 to 5. Next offset will be 5 to 10, and next will be 10 to 15. So that offset is nothing but what place exactly the fragmentation of the original fragmented IP packet is done. So the place where exactly it is done, offset is nothing but the place, the count, the place where the fragment is done. So that it has to be notified. Next, time to live. The packets which are sent across the networks will not stay for more than specified time. That specified time is your time to live. So if you specify 10 seconds, within 10 seconds the packet has to reach the destination, or else the intermediate node will delete that particular frame. Why this? Because there are various reasons where sometimes packets may lose the path. So packets may lose the path due to miscalculation or corruption, due to corrupted address. It may lose the path. It will never reach the destination. It will be keep on roaming. So if you don't set the time to live, what happens? It will be keep on roaming, and that will create much more what do you call congestion. So time to live, it will be specified by your ICMP, so internet control message protocol. And if the time exceeds, automatically what happens, the packet will be destroyed. So that is one. And every time when it moves from one intermediate node to another intermediate node, or one router to another router, automatically each router will reduce the time in this. So if the time is 5 seconds, automatically it is moving from node A to node B. Node B will write 4 in this place. Node B to node C. Node C will write 3. Node C to node D. D will write 2. Node D to node F. F will write 1. Node F to node E. So by the time it reaches node E, that is the destination node, this should become 0. If it is not reached the destination, means automatically node E, if it is not the destination, automatically it will delete this particular packet. It will destroy, because to avoid congestion. So that is the reason we have time to live. Time to live is a binary value used to limit the life cycle of the packet. So sender will initially write the this value, TTL value, and each intermediate node will decrease by each time the packet proceeds by the router. Router will, if the field is 0, automatically, if as is decreased, if the value becomes 0, then ICMP, internet control message protocol, ICMP will delete this particular frame, so our frame or packet. So that is the one. Next, the protocol. What is the protocol you are supposed to use it? Whether you are using ICMP to delete this internet control message, or you are using UDP protocol, or you are using TCP protocol. What is the protocol that it has to carry? So internet protocol certainly carry the upper layer protocols. So upper layer means transport layer. Transport layer has many protocols. So those protocol numbers are written in this protocol field. So in this field, those protocol numbers are written. So those protocol numbers. So here you observe ICMP value is 1. So if it is ICMP, internet control message. So if you are transferring any control message, so it will be 1. If you are transmitting TCP protocol, if you are following, it will be 6. If you are following UDP, yes, it will be 7. So it is just like that. What is the protocol that is it is following from the upper layer, higher layer? That's what you have to understand, and you have to get it. And header checksum. Checksum is nothing but it is the total bits, 16-bit used to check the correctness of the frame. So as soon as it transmits from one node to another node, or one router to another router, each router will check whether this particular frame or the packet is correct or not using this checksum field. So we have discussed this checksum field in the previous module. So the same procedure, it has been followed here also. If the checksum is not matched, automatically it is an error in the header, automatically that particular frame will be deleted. That particular packet will be deleted. That is how it happens. That's how it happens. And further, source IP, it is the IP address, 32-bit IP address, 32-bit IP address of the source machine. Same way, destination IP. Destination IP is the to which it has to be sent. And finally, the options. Options will have optional fields which are being used by internet header header life, so which is greater than 5. These options will certainly hold what is the security you are using, security codes. If you are using, you are using any recorded route, so if you have any timestamp, so what time it has reached, what time it has left, so all those information will be stored in this option field, in this option field. So in the examination, if they ask about IPv4, so this question will be generally comes for 10 marks, and definitely I'll give a assignment on this. And this is one of the very important question that you have to consider for the examination. That's a very important thing. So that's all for today's class. Next class we'll discuss about further routing protocols. Now the entire class recording will be there in this particular website, and also it is available, the study materials are available. So now let us not waste our time. We will quickly move on to the revision. So I was just doing the revision. So last class we discussed what are the applications of network, what are the requirements. So requirements of different people, application programmer, network operator, network designer, what their requirements, what is point-to-point link, what is multi-access link. We discussed what is a cloud. We discussed what are the two components available: circuit switch and packet switch. Circuit switch will create a circuit before transmission. Packet switch will split the message into small packets and it will transmit over the network. You can connect the clouds, multiple clouds, using the routers. Routers are gateways, we call it as. Now that's what today we discussed. And addressing, we have unicast addressing, we have broadcast addressing, and multicast addressing. Unicast is to transmit to only one person. Broadcast is to transmit to everybody. Multicast is to select particular people and send. And multiplexing in one single line, multiple channels used to transmit the data. So we have time division multiplexing, their advantages and disadvantages, frequency division multiplexing, advantages and disadvantages. Finally, we come across statistical time division multiplexing, just to avoid this wastage of channel time. So that is what we discussed. And we also discussed this is where we stopped in the last class. And so now coming on to the classification of computers. So we have networks can be classified based on their connectivity. PAN, personal area network, so LAN, local area network, we discussed, and MAN, metropolitan area network. So we discussed, and finally wide area network to connect various computer. Storage area network, just to store. And we also discussed the architecture. So we have two architectures available. The first one is 7-layer architecture. We call it as OSI, 7-layer architecture. Very, very important, 7-layer architecture. And another one we have TCP/IP. So physical layer, mainly responsible physical connection. Data link layer for connecting, creation of frames, error detection. Network layer, finding the routes. Transportation layer, process to process message delivery. Session layer to establish session. Presentation layer to present the data appropriately. And we also discussed the differences and common components between OSI model and TCP/IP model. We discussed about all these different things. That was in the last class that we have. And apart from this, yeah, we did comparison. We did. So next one is implementation of the network software. Implementation, when it comes to implementation of the network software, so we come across network application program interface. So we call it as sockets. So this is called sockets. Sockets are communication objects where you certainly connect 2 or 3 computers together and you transmit. So in the socket, first thing is you have to create the socket. So socket creation. So here you come, you will get 2 computers. One is a server, one is a client. Socket has to be created in both, and they have to be first. Socket has to bind to the server, and it has to start listening, and it has to, once it is listening, it has to accept the connection. So once it is listening, the bind operation will bind the address, IP address, to the server IP address to the socket. The same IP address will be used by client side, and it will connect. It will send a message called connect. So it will accept for the connect, and it will wait for the connection. Once that connection is done, it will send. So connection response will be sent, and based on that, what happens? It will send for a request. Send is the method to send the request, and receive is a command to receive. At the other side. Once it is received, the request is processed, and the response is sent back. You can see again here send. Send is happening in the server side, and finally the response will be received by the receiver, the client. So based on this, we have written the program. I have explained the program earlier also. So same program we had to practice well. What is bind used for? What is listen used for? What is connect is used for? What is send is used for? What is receive is used for? And various steps, algorithm, the entire program I just given. So this is the software implementation. In the next class, we'll discuss about some of the performance issues, and we'll discuss about some of the problems, so that the entire module 1 revision will be completing in the next class. And in the Google class, I have already given the announcement. I have made the announcement regarding what you have to do, the practice test. So you have to go to a particular website and do a lot of practice test. So based on those practice tests only, you will be able to easily and take up the internal test, CN internal test. It is on 30th of this month, April 30th. So you can certainly do it. So prepare seriously on all these internal tests. Do well, and that's all for today's class. Have a wonderful day. Thank you. We'll meet in the next class. If you have still any doubts, if somebody has not yet joined the Google class, you are supposed to join. Just join to the Google class. Go to your Google class and type the Google class code. Certainly you can join. That's all for today's class. Have a wonderful day. Thank you.